Solve one problem on static force analysis of slider crank mechanism by using first principle of virtual work, second graphical method.
Let us understand the formula used to calculate torque T in slider crank mechanism by using principle of virtual work. This is the crank OA. The end of this crank is pivoted at point O. Then AB is the connecting rod and at end B there is the slider. Because of the applied force F on the slider, there is the displacement in the slider. So I will show this displacement dx taking place in slider with the help of red marker. So this is the initial position and this is the final position, and this displacement is dx. Now this is the linear displacement dx. Now the forces are transmitted through this connecting rod and there is the angular displacement in the crank. So this angular displacement we will show, that is d theta. Now we will join the points. Now when this slider crank mechanism tries to displace from its original position, then there is the applied torque T, and we have to apply this torque T in the opposite direction. So here is the direction of the torque T. Now how to find out the formula for this applied torque T? By using the principle of virtual work. So according to this principle, work done during virtual displacement from the equilibrium is 0. Now let us first find out the work done during the displacement of this slider crank mechanism. So if we observe, this is the linear displacement for this slider and here is the angular displacement for this crank. Now work done with linear displacement, that is force multiplied by displacement. So applied force is F and displacement is dx. Now when there is the linear displacement, then in this crank there is the torque is to be applied through an angle d theta to bring the system into equilibrium. So here work done with angular displacement. So work done with angular displacement is related to crank. So here we have to write here as a T into d theta. That is torque into d theta. Now according to the principle of virtual work, this total work done during virtual displacement is equal to 0. So according to the principle of virtual work, we should write here F dx plus T d theta, that is this total work done, is equal to 0. So which is equal to 0. Now this displacement is a function of time t. So we will differentiate this equation with respect to time t. So how to differentiate this? So F dx by dt plus T d theta by dt is equal to 0. Now we know that dx by dt is nothing but velocity and here d theta by dt is nothing but angular velocity. So how we can write this? So we can write this as a F multiplied by velocity, that is linear velocity of slider. So I will write here as a slider plus T d theta by dt, that is the angular displacement of this crank. So omega crank is equal to 0. So how to write this formula T? So T is equal to minus F into V slider divided by omega crank. So this is the formula that we have to use to calculate this torque. We will solve one problem by using the formula for torque T. The crank OA is given 100 mm and the angle AOB is equal to 120 degrees. So we have to draw first one horizontal line and along that horizontal line we will consider any point as a point O. then at angle of 120 degree, so from this horizontal line, this angle is 120 degree, we will draw one line with some suitable scale. So we will consider here 1 centimeter, so scale will be 1 centimeter is equal to 10 millimeter. So according to this scale, for 100 millimeter we have to use distance 10 centimeter. So at 10 centimeter at 120 degree we will take here one point A. Now this point A is known. Now the distance AB is also given for 50 millimeters. So according to this scale, we have to take a distance of 45 centimeter in compass and slider reciprocates along this horizontal line. So we put the center, or we will take center as a and at 45 centimeter we will mark here one arc, and this arc will give us the point B. So the point of intersection of this horizontal line and this arc is nothing but point B, and at this location we have to draw here one slider. So in this way this diagram is getting completed. Now the applied force is given 2 kilonewton. So on this slider there is the force F is to be applied, and that is equal to 2 kilonewton. Now we have to find out the torque T. So for the equilibrium of this mechanism, we have to apply the torque T in opposite direction, that is in this direction. So we have to find out the magnitude of this torque T. So we will first draw the velocity triangle. So to draw the velocity triangle, we will first find out what is the velocity or linear velocity for this crank OA. So what is the formula? So I will write here linear velocity of crank OA. So we will mention this with V to the base OA. So here I will use the small letters. Now if we observe this point O, this crank is pivoted at this point O, and this point O is fixed. So we can say that velocity of A with respect to point O. So VOA. So how to find out? So what is the formula? So formula is the angular velocity multiplied by this length. So length is given 100 millimeters. So we will convert it into meter, that is 0.1 meter. So the standard unit we have to use. So we will take here as a 0.1 meter multiplied by, that is this length multiplied by angular velocity. So angular velocity is omega. So omega OA. So this is the formula. So I will simply write 0.1 omega. So this is the linear velocity for this crank OA. Now how to draw the velocity diagram? So this velocity is always perpendicular to this link. So how to take this perpendicular direction? So we have used this protractor whose two edges are perpendicular to each other. So if I align one edge with this link, then the other at this other edge we will show here the perpendicular line. Now in the same way for this connecting rod AB also we have to show the perpendicular line. So how to show this? So I will align one edge, and along this second edge here is the perpendicular line. Now we can easily draw the velocity diagram. So for that we will take some suitable scale. Now here force 2 kilonewton is given. So force is also given some direction. Now this point O as well as this point G, that is point G is there where this slider is fixed. So these two are the fixed points. So I will locate here one point, and I will show that this point will be O comma G. Now we have to take some suitable scale because this velocity is 0.1 omega. So I will consider this 10 centimeter is equal to 0.1 omega. So we will take the scale for 1 centimeter. So for 1 centimeter, what is this? 0.01 omega. So this is the scale. 1 centimeter is equal to 0.001 omega, and according to this scale we will draw the velocity diagram. So for this velocity for the link O to A, I have to take the line parallel to this. because the velocity is in along this line, because this line is perpendicular to the link OA. So now along this line I will show here, and we have to take distance that is equal to 10 centimeters. So here this is the line for 10 centimeters. So this is the fixed point, and this is the velocity of A with respect to O. So how to give the direction? So direction we have to show here, and this point will be point A. Now after point A, this point A is connected to this point B. So now we don't know the direction, but we know the line. So along this line there is the velocity of this link AB. So how to show this? So I will show here, this is the velocity of A with respect to O. Now I will show the velocity of B with respect to A, because B is the final point and A is the initial point. So along this line, so I will show here, or I will draw one line passing through this point A, but parallel to this. So this is the line. Now because this slider reciprocates along this horizontal line, and this is the fixed link, that is point O is also fixed and this line is also fixed. So this point G is also fixed because this slider reciprocates along this horizontal line. So we have to show here one line passing through these two fixed points O comma G, but it should be horizontal. That means we have to show here line parallel to this. So I will show in the form of dash. Now if we observe, this point of intersection is nothing but point B. This point of intersection, because this is the line for the velocity of B with respect to A, and this point of intersection is nothing but point B. So how I define this line? That is velocity of B with respect to A, because B is final point, that's why VBA. Now we will give here the direction, that is in the upward direction. A is the initial point, B is the final point. Now this is the velocity of the slider, that is the velocity of B with respect to G. So how we can show this? So here B is the final point and G or O is the initial point. So I have to show direction towards point B. So I will show here the direction. So I will convert this dash into one single line, and I will show here. And here velocity of B with respect to G. Now this velocity of B with respect to G, that is VBG, is nothing but the velocity of the slider. Now with this, by measuring this distance, we can easily find out what is this VBG. So I will measure this, and it is equal to 8.5 centimeters. So VBG is equal to 8.5 centimeters. Now we will convert it into the scale. So 8.5 multiplied by 0.01 omega, and that is equal to 0.085 omega. So this is the value of VBG. Now we will apply the formula according to principle of virtual work, and this formula is T is equal to minus F, linear velocity of slider, divided by angular velocity, that is omega crank. So according to this formula, now we know what is the velocity of the slider, that is VBG, that is equal to 0.085 omega. So we will put this value. Now force applied, that is given in the question, 2 kilonewton. So we will write here minus 2 into 0.085 omega divided by omega. Now this omega is getting cancelled, and when we calculate this, then we get the answer torque T is equal to minus 0.17 kilonewton meter. So here unit is kilonewton meter because force applied is given in kilonewton. So this is the answer. Now why here minus sign? Because if we observe, this applied force is acting towards left hand direction, and this torque we have to apply in opposite direction, that is towards the right hand side direction, and that's why there is negative sign. Now we will solve this same question by using graphical method. Now if we observe the question here, the length of crank OA is given 100 millimeter and the angle is given, that is from BOA, that is 120 degree. So we have to first draw this horizontal line and at angle of 120 degree with scale 1 centimeter is equal to 10 millimeter. We have to draw this crank, and then the length of connecting rod 450 millimeter is given. So with this scale we have to take 45 centimeter distance, and with the help of compass mark here one arc, and with this horizontal line and this arc, point of intersection will be the point B, and this is the length of the connecting rod AB. And at this point B there is the slider, and slider is getting reciprocated along this horizontal line. Now force F is applied on this slider, and because of applied force F, this mechanism tries to displace from its original position. And to bring the system in equilibrium, we have to find out torque to be applied on this crank OA. So we have to find out what is the magnitude as well as direction of this torque T. Now when we solve the question by using graphical method, then the first step is to identify the types of members. So we will first give the numbers to the link. So this horizontal line, that is the fixed link, so I will give here number 1. For this crank OA we will give number 2, connecting rod number 3, and for this slider number 4. Now if we observe crank OA, then through this point O, force F is transferred from 1 to 2. So F of 1 to 2. Then through this point A, force is transferred from 3 to 2. So F of 3 to 2. Then there is torque T. So this crank OA is 2 force, 1 torque member. Then we will move to the connecting rod. So through this point A, force is transferred F of 2 to 3. Then through this point B, force is transferred F of 4 to 3. So this connecting rod is 2 force member. Now we will move to the slider B. So for the slider B, through this point G, the force is getting transferred F of 1 to 4. Then this slider is connected to this connecting rod, so force is transferred F of 3 to 4. And there is applied force F, that is also applied on the slider, so there is force F. So this is the 3 force member. Now next step is to draw the free body diagram. So how to draw the free body diagram? So with reference to this, we have to take the line parallel to OA, and we have to consider the same length as mentioned in this diagram, and we will take here this 10 centimeter and here is the OA. In the same way, connecting rod AB we have to transfer, that means the same length we have to consider, that is 45 centimeter, and we have to transfer this as it is. Then for the slider B, along this horizontal line, because slider reciprocates along this horizontal line, we have to show this point B. So here this is the point B. Now we will move for this line of action of force. We know that for a 2 force member, the line of action of force is along that link only. So this member AB is having 2 force. So I will show the line of action of force along that line. So I will show this in the form of dash. So through this point B, which force is applied on this connecting rod? So F of 4 to 3. So this line of action of force for F of 4 to 3. And through this point A, which force is applied? F of 2 to 3. So we have to show here F of 2 to 3. Now if we observe, here is crank OA. So this crank OA is the 2 force and 1 torque member. So for this 2 force and 1 torque member, what is the rule? So rule is that the line of action of forces are parallel to each other. So now through this point A, I will show the same line of action of force. So same line of action of force, that means line parallel to this line of action of force and passing through this point A. Now for this crank OA, which force is there? So through this crank point A, F of 3 to 2. So this is the line of action of force F of 3 to 2. Now forces are parallel to each other. So I have to show here one line parallel to this but passing through O. Now through this point O, which force is there? So F of 1 to 2. So this is the line of action of force F of 1 to 2. Now we will move for the slider, that is the link force. So through this point B, if we observe F of 4 to 3 and F of 3 to 4, these two forces are in the same opposite in direction and equal in magnitude, but same line of action of force. So through the point B, I have to show the same line of action of force by taking the line parallel to this. So we have to show this line in the form of dash, and B is the center. So through the center we have to show. Now force F is also applied, because if we observe the slider B, this line of action of force for F of 3 to 4, because F of 4 to 3 and 3 to 4 are in the opposite direction but having the same line of action of force. So I will show here, or we have to mention F of 3 to 4. Now force F is applied towards the left hand side direction and at the center. So at the center we will show here the force F. Now the slider B is the 3 force member. So we have to find out what is the concurrent point. So if we observe, if we extend this F, then it intersects at the center to this F of 3 to 4. Then the center is nothing but the concurrent point. Then what is the rule for this 3 force member? That the third force should also pass through that concurrent point. So third force, which is the third force, F of 1 to 4. So this link 1 is the fixed link. So we have to show this force that is in the vertical direction. So through the center we will show, because the third force should also pass through this concurrent point, and we will show here the line of action of force. So this line of action of force is for F of 1 to 4. Now we don't know what is the magnitude as well as direction for all these forces. This slider is the 3 force member, and we have to show here the force polygon. Now out of these 3 forces, there are the 2 forces which we don't know the magnitude as well as direction. But for the force F, we know the magnitude as well as direction. So F is equal to 2 kilonewton and direction is towards the left hand side. So we will consider one suitable scale. 1 centimeter is equal to 0.2 kilonewton. So according to this scale, for 2 kilonewton we have to take scale 10 centimeter. So we will draw here 10 centimeter line. This is the tail of force F and this is the head of the force F. Now we have to select any one force passing through this head. So I will select here F of 1 to 4. So this line of action is in the vertical direction. So I will draw here this vertical line. Now the next force, that is the remaining one force, we have to pass through the tail of the force F. So we will take here this line of action of force and we will draw one line passing through the tail. So here is the intersection point. Now this force polygon should be closed. That means at the head of force F there should be tail of the next force. So this vertical line is for F of 1 to 4. and then at the head of f of 1 to 4 there should be tail of the next force, that is f of 3 to 4. So we have to show arrow here. So this is the closed vector polygon. Now we will calculate the magnitude of force f of 3 to 4. So for that we will measure its length, and this length is equal to 12 centimeters. So as per the scale, 1 centimeter is equal to 0.2 kilonewton. F of 3 to 4 is equal to 12 multiplied by 0.2, that is equal to 2.4 kilonewton. Now what is the direction of this f of 3 to 4? So that is towards the right hand side direction. So we will mention here the direction of f of 3 to 4, that is in this direction. We will also mention the direction of f of 1 to 4, and this is in the upward direction. Now through this point B, we know that f of 3 to 4 and f of 4 to 3 are equal in magnitude but opposite in direction. So we have to show f of 4 to 3, the direction is in a opposite side, that is towards the left hand side. And what is the magnitude? So magnitude of f of 4 to 3 is 2.4 kilonewton, because it will remain same. Then f of 4 to 3 and f of 2 to 3 are equal in magnitude but opposite in direction. So I will show here the direction in opposite direction, and the same magnitude, that is 2.4 kilonewton. Now f of 2 to 3 and f of 3 to 2 are equal in magnitude but opposite in direction. So I will show here the direction. Now what is the rule for 2 force and 1 torque member? That means this direction of forces are opposite direction. So we will show here the direction for f of 1 to 2, that is in the opposite direction. So if we observe, these two forces form a couple in this anti-clockwise direction. So we have to apply the torque in the clockwise direction. So here is the direction of torque T. Now f of 3 to 2 is equal to 2.4 kilonewton. Now we don't know what is the magnitude of this torque T. So how to find out that? So for that we have to first find out the perpendicular distance in between them. So with the help of protractor, I will align one edge with this one line, and now I will draw here one perpendicular line. So this is the perpendicular line, and now we have to measure this height h. So this height h is equal to 7 centimeters. So h is, I will write here, h is equal to 7 centimeter. But according to this scale, say 1 centimeter is equal to 10 millimeters. So 7 centimeters is equal to 7 multiplied by 10, that is 70 millimeter. And this millimeter we have to convert it into meter, 0.07 meter. Now how to calculate torque T? So this torque T is equal to this force. So any one force we can select, because these two forces are equal in magnitude but opposite in direction. So torque T is equal to f of 3 to 2 multiplied by height h. So 2.4 multiplied by 0.07. Now when we calculate this, then we will get the answer 0.168. So we can approximately write this 0.17. Now what is the unit? So unit is, because this force is in kilonewton and h is in meter, so unit is 0.17 kilonewton meter. So if we observe, by the principle of virtual work, answer was same, that is 0.17 kilonewton meter, and by the graphical method also the same answer, that is 0.17 kilonewton meter.